Good morning, girls. We will continue the same topic, the law of conservation of momentum. Children, yesterday I had explained you what is this law, right? I also gave you one example to understand how is this law of conservation applied in the actual objects. Like the law states that if two objects are colliding or if two objects are interacting with each other, what happens? The total momentum before and after the interaction remains the same, or it remains constant, remains conserved. Okay, so I also told you that there is a formula, that is m1u1 plus m2u2 is equal to m1v1 plus m2v2. Okay, so you today I will explain you the whole derivation of this formula, and you can write this in your notebook. It is also given in your textbook. If you want, if you have any problem, you can refer to your book. Otherwise you can ask me your doubt. Okay, now we are going to derive the formula for the law of conservation of momentum. So you will listen to me carefully. There are two objects, A and B. Okay, this has a mass m1 and this one B has mass m2. Okay, now we assume that both these objects are moving in the same direction. Okay, both these objects are moving in the same direction with different velocities. So again, we consider two objects and let those objects be A and B respectively, right? Their masses are m1 and m2, and the velocities are u1 and u2. Both are moving in the same direction, but the velocities are different. So this is m2, this is u1, this is u2. Okay, and this is m1. Now both of them are moving with the different velocities, so we assume that u1 is greater than u2. Okay, and we assume that they collide. Okay, this is before collision. We assume that they collide. When they collide, they stick to each other, right? And they exert force on each other. Okay, I repeat, we assume that they collide. Okay, when they are colliding, they are exerting force on each other. A is exerting force on B, B is exerting force on A, and let those forces are F1 and F2 respectively. Okay, now as you can see in the diagram, that if A will exert force on B, it will be in this direction, right, or in the right direction. When B exerts force on A, it will be on the opposite direction, that is towards me or towards the left side. Also remember that these two forces are equal, F1 and F2 are equal, and they are opposite in nature. So we can take as F1 is equal to minus F2, according to which law? The third law of motion. Okay, now you also remember that this interaction or this collision take place for time t. We don't know the exact time, what time the interaction take place. Any two objects, when they collide, what time they are interacting for. Here in this derivation we assume it to be t. Okay, now this is before collision, this is during collision. During collision they are exerting force, and after the collision what happens? They don't stick together, they don't remain in the same position, they move in the same direction, that is maybe this side or this side, by the different velocities. Here the velocities were u1 and u2 respectively, now v1 and v2 respectively, because the velocities will change after interaction. It is not necessary that they will move with the same velocities. So we assume that the velocities after interaction changes. This is the after interaction diagram. Okay, and so when you are writing this derivation in your notebook, you will draw three parts, that is before, during, after the collision. Maybe I will use the word sometimes collision, or if I use the word interaction, both have the same meaning over here. Now, okay, now the initial momentum of object A is m1 u1. Initial momentum of object B is m2 u2, because momentum is given by mass into velocity. Then A, final momentum is given by m1 v1, and the final momentum is given by m2 v2 for object B. So did you understand all this? before interaction, during interaction and after interaction. Before interaction, their momentums are m1 m2, m1 u1, m2 u2. During interaction, they are exerting force on each other, and after the interaction, they move in the same direction but with different velocities. Okay, now as you can see that from here it was initial velocity and this was final velocity. Therefore, we can say that these objects are accelerating. You know what is acceleration? Acceleration is given by the change in the velocity of the object per unit time. So here there is a change in the velocity. So we can say that these objects are accelerating. So we have to use, we can use, okay, wait. Right. We have to use this term acceleration because there is a change in the velocity of the two objects. Now, you also know that F is given by mass into acceleration. Okay. As I told you that there are two forces here, F1 and F2. F1 is a force exerted by A on B. Okay. And F2 is a force exerted by B on A. Yes. Now, when A exerts force on B, there will be a change in the momentum of object B. Okay. If A, this is A, if A exerts force on B, that is this is B, there will be a change in the momentum of object B because this is exerting force on B. Similarly, when this object B exerts force on A, that is this object, there will be a change in the momentum of object A. Okay. So therefore what happens, we will write F1, I told you in the previous explanation that F1 is equal to minus F2, right? Now, we know that F is given by the formula what? Mass into acceleration. Now, acceleration is equal to V minus U upon T. This is according to the first law of motion. Okay? First equation of motion which we have done in chapter motion. Not first law, first equation. Yes. Now I will substitute the value of F1 and F2. Now what is the value of F1 and F2? F1 is force exerted by A on B. So there will be a change in the momentum of object B. Therefore I will write for F1 M2 V2 minus U2 upon T. What is T? T is a time interval for which the interaction takes place. Similarly here minus force exerted by B on A, there will be a change in the momentum of object A. So therefore M1 V1 minus U1 upon T, and therefore now I will open this bracket and then solve. M2 V2 minus M2 U2, T and T this side I will cancel. Yes, here I will get minus M1 V1 plus M1 U1. Now I will rearrange the terms. M2 V2 plus M1 V1 is equal to M1 U1 plus M2 U2. So as you can see that M1 V1 plus M2 V2 is equal to M1 U1 plus M2 U2. That means the total momentum, that is the final momentum of the two objects, is equal to the initial momentum of the two objects. That is, according to the law of conservation of momentum, the total momentum remains constant or remain conserved. This is proved from this complete derivation that the total momentum of the objects before the interaction and the total momentum of the objects after the interaction remains same, remains conserved, always remain equal, provided no external unbalanced forces acting on them. Okay, now children, this completes your chapter. Okay, the law of conservation of momentum was the last topic. Now what you will do is you will go through this complete derivation and you will write in your notebook, right, and learn the law. And if you have any doubt, you can ask me, and in the next week I will be solving the questions from the exercise, that is exercise textbook. There will be some numericals also. In between the chapter also you can go through the questions. If you have any doubt, you can ask me. You can also try the questions yourself, okay, but I will do it with you. Okay, and any doubt you can ask me, and see that you complete your work, children. And thank you. Have a nice day.